Hi, as I said in the previous episode, let's practice, which is better in some cases than theory. This is the exercise 1 with the following context. Measurements are made of the tensile strengths of 12 steel rods, of which 6 rods have received special treatment and the remaining 6 have not received any treatment. On the evidence of the measurements, does the special treatment increase the tensile strength? Perform appropriate parametric and non-parametric tests at 5% level of significance. In the first paragraph, we can see that we have two independent samples. The first represents the 6 rods who received special treatment, and the second represents the remaining 6 who did not receive any treatment. This question on the second paragraph is very important because it will help us on the last step, which is the conclusion. According to the question, we can say that we have two independent samples, right? So, which parametric test we should use? Two samples independent test. Instead of saying the 6 steps, let's call it the big 6, which are fundamental to perform well an hypothesis test, such as defining the hypothesis. The null hypothesis wants to show us that the first and the second mean are the same, which the first mean represents the tensile strength of the 6 rods who have received this special treatment, and the second represents the remaining who haven't received any treatment. The alternative hypothesis wants to show us that the first mean is greater than the second. Then number 2, level of significance, which the previous text show us that we are going to use the 0.05 level of significance. Then number 3, p-value. For this step, we must perform the 2 samples independent t-test for the parametric, which I have explained on the previous episode. Let's go to STATA. First, let's check the dataset. We can see that we have one group variable represented by the rods with treatment and the rods without treatment. The second variable represents the tensile strengths or the values of the tensile strengths. Let's perform the parametric test. T-test, then the tensile strengths by the group variable, which is treatment. And voila, how we can interpret these results. Okay, first we need to take a look on the difference between the mean. And the difference is difference of 0 and is less than 0, which is this value. It is minus 0.7. So we can use one of these two p-values, this one or even this one, but not this one, because this one is only used if the difference is greater than 0, which is not. So let's use this one. The 0.038 will be our p-value. Criteria of rejection, the number 4. We have already the result of the p-value and we have defined the level of significance. The criteria of rejection is if the p-value is less than the level of significance, we reject the null hypothesis. Now going to decision, which is the number 5. Since the p-value is less than the level of significance, we reject the null hypothesis. And then the last, conclusion. Do you remember the question in the second paragraph? Let's take a look. Does the special treatment increase the tensile strength? Now we can make a good conclusion based on the question. We conclude that the tensile strengths of the 6 rods who received special treatment are greater than those of the remaining 6 without any treatment. Now, for the non-parametric, We don't need to have too much work. We only need to change the test, which will be the Mann-Whitney test. We just need to get the result of the p-value and the remaining steps. We already have the hypothesis, the level of significance, but we must perform the Mann-Whitney test so that we can have the result of the p-value. Let's go to STATA. And voila! Now we have the p-value, which is 0.049. The criteria of rejection. We know already. What will be the decision and the conclusion? I'll leave it for you to write down the comments or even to practice by yourself. And I'll leave also the dataset on the description of this video. Enjoy and see you soon.